For test number 2, practice/review, let's look at number 3. The question says, find a second-degree polynomial such that p of 2 equals 5, the derivative of p evaluated at 2 equals 3, and the second derivative evaluated at 2 equals 2. So the first thing that I did was wrote down the general form of a polynomial. Ax squared plus bx plus c. Then I plugged in the value that we were given of x equals 2 into our polynomial. So I have a 2 squared plus b times 2 plus c equals, that's 4a plus 2b plus c, and we're told that when I plug in 2, I get out 5. So now I have this equation, 4a plus 2b plus c equals 5. Next, I'm going to take the derivative of this polynomial. So I take the derivative of p, and I get 2 times a times x plus b. Then when we're told that when we plug in 2 into the derivative, we get out 3. So I plugged in 2 into the derivative, and that simplifies to 4a plus b then equals 3. Finally, I take the second derivative of p. And the second derivative, I start with p, I took the first derivative, and then the second derivative is now 2a. We're told that when I plug in 2 into the second derivative, I get out 2. Plugging in 2 into the second derivative, I get 2a, which is equal to 2. Solving for a, I find that a equals 1. Then, with a equaling 1, I plug a equals 1 into my equation. 4 times a plus b equals 3. 4 times 1 from this a equals 1 plus b equals 3. And I find that b is equal to minus 1. And then finally, from 4 times a plus 2 times b plus c equals 5, I plug in the a equals 1 and the b equals minus 1, and I solve for c and find that c is equal to 3. Now I have the values of a, b, and c. A